So what we're going to do today is examples from the homework. We're going to do we're not going to do the exact homework, but we're going to do similar problems, that like very, very similar problems to the homework. And I want to try to get through all A through K, or find ones that are very much, that's what we're going to do. We're going to find ones that are very much like A through K, so that you have an example of each one of these different types to do. And the idea with this is, so this is what we did in class. I'm going to keep this up here to kind of as like a roadmap for what we should be doing. And that's what this is, right? Like if we were so inclined, we could just take our original problem, whatever those three numbers happen to be, A, B, and C, and we could just plug them into this formula, because each one of these lines is equal. It's exactly equal. And we could, if we wanted to, memorize this formula and then just take whatever we're given and just plug it into here. But that's not what we want to do. It's actually much harder to try to memorize a formula. It will be to your benefit to get this down, this algorithm, because that's what I've laid out here as an algorithm. This is what we're going to do. And this is, like I said, our roadmap. We're going to use this for comparison as we go along. And I presented it this way in order to do that. Like now we have a roadmap. And so then after doing like 10 examples, which is what we're going to do today, then you could see better how to use it. And so by the end of this, you should, I guess the biggest point with the homework is that by the time you're done doing this, you should believe it. And written like this, it's hard to believe. It seems alien and it's weird, and I know that, and that's part of it. But by the time you get through 10 of these, you go, no, yeah, I see what this means now. And so that's what we're going to do. Any questions before we start?
No.
Nope. Okay. So we're going to start with a very similar one to problem A. And we're going to do x squared minus 2x. How about plus 1? Okay. So this is our given thing. We can see the A happens to be a 1. The B is a -2. All right. And the C is a +1. So the first thing we need to do is give ourselves some room. So that's what I'm going to do. I'm just going to say, okay, x squared minus 2x, give myself some room. Put that 1 way over there. Okay, now the next step says to factor out an A. Now, okay, well, first off, the A is a 1. We don't need to do that. If we wanted to, we could go ahead and write this as, well, let's see, if there's a 1 here, we could pull out the 1 and have the x squared, and then this says that we divide by the 1, minus 2 over 1x, right? This would be what step 1 says to do. But of course, that's a 1. We don't, in this case, we don't need to worry about this part actually factoring it out. But this is what this says, is to do that. But we're not going to use, actually, and the only reason to have these parentheses in here is because of that A term. But when the A term is 1, you don't need parentheses. So in this case, and in this case only, when you don't have a number that's not 1 right there, then we don't really need all of this right here. And so this is going to be the one time where I'm going to say, you know what, we actually don't need that right there. This is already in the form that we want. Parentheses, I'm just using these just to kind of show right now, this is where the action is. And this thing we now need to turn into a perfect square. And so what does this say to do? Well, it says that we add, this says 1/2 of whatever this is, right? Because B over A, in this case, it's 2 over 1. And then we take 1/2 of that, in other words, right? So this is the B over A part that I'm looking at right here. Happens to be 2 over 1. This says take half of it. In other words, B over 2A would be, in this case, 2 over 2 times 1, which is, and okay, yes, we're just taking half of 2. That is just 1. And so to complete this, to make this a perfect square, we need to add on b over 2a, in other words, half of what that is squared. And so I'm even going to write it with parentheses. But then I need to subtract it off because I don't want to change the overall value here, which is a really weird step. I get that. That's an odd thing to do. And that's one of the conceptually, that's probably the hardest part of all of this. But we could just go back and check. Let's just make sure now. And every time I do this, as we're doing this, it's really good in order to believe that this is true. That's Keila. That's right. Every step along the way, we just kind of check. Is this the same thing as that? Well, yeah, I just moved the 1 to the right. I didn't do anything. Is this the same thing as that? Well, it doesn't look like it, but this says to take +1 minus 1, which is just 0. Yeah, okay, so that's a big 0. And then this is just x squared minus 2x. Yep, that's just a +1. Yeah, it's the same thing. But now, and this was the whole point, right? Now let's not even look over here. If I told you to factor this bad boy, hopefully you would say, hey, that's a perfect square, right? Like, you should be able to notice that this is a perfect square. But even if you didn't, if you just went to factor it the old-fashioned way, you'd say, well, there's an x here and an x here. What times what is 1? Well, I guess 1 and 1, that's it. I have my outer is 1x, my inner is 1x. In order to make that a minus 2x, I would need them both to be minuses. Oh yeah, that's what that is. And it happens to be a perfect square. But of course it was going to be. That's why I did that in the first place. That's what that does. Remember, like, that's the whole reason we could have chosen to add anything here. But we chose to add half of the middle term squared because we knew that that was going to give us a perfect square. And so that's what we're doing here. We're going to say, okay, that is a perfect square. And now I can rewrite him as x. I'll give myself a little bit more. This guy is x. Now, and be careful here, right? Because we're not just plugging this into the formula, right? If we do that, if we were actually doing that, we'd notice this is plus b, but b is a -2. So we just have to be careful here when we go to from this side, this to this. If this is going to be a perfect square, remember, then this sign determines what sign is in the square. And then whatever part is squared out here, that's the part that goes right there. So I've now just reduced this entire thing right there down to that number. And we ended up picking up a -1 squared. So now we're at this part right here. And let's just check, make sure that all of this is still true. If I squared this bad boy out, I would get this guy right here. Yeah, that would be up there. That -1 would be right there. The -1s, the +1 -1 would be gone. And yep, I'd still have that, which would still be that right there. Now, this next step here says to factor the a back in. Well, our a was 1. Again, if I wanted to, I could have put a 1 out here for the a, but it's pretty easy to see that when we bring the a back in, it doesn't change this. We could just drop parentheses. Now we're at this part right here. And at this part, right, this is like, we don't need to worry about that because, well, this, again, this stuff, it's not like we're not starting with this and then plugging a bunch of stuff into here. If I wanted to, I could have from the very beginning, and let's just see what I'd have. 4 times a times c, a is 1, c is 1, minus b squared, b is -2 squared, over 4 times a is +1, 4 times 1 times 1 is 4, minus +4 all over 4. Oh, that's 0 over 4. That's just a 0. And hey, what do you know? It's going to come out to be 0, right? So my point with all that is, again, we're just all of this stuff is just manipulation for what it would look like if A, B, and C were a bit more complicated. In this case, it happens to be nice and simple. And we're not going to, if we can easily see, like, yes, 2 divided by 2 is 1. I'm just going to write it as 1. We're not going to continue to write it in these fractions and stuff like that. It reduced nicely, so we don't need to go through all that rigmarole of fitting it into this, into this form or into that shape. We could just say, okay, finally, x minus 1 squared minus 1 squared is 1 plus 1. These guys cancel. And so we're left with just x minus 1 squared. It happened to be a perfect square. What do you know? And like I said, this is not the actual homework problem, but this is that. So now part 2 is we want to check this, right? We went through all this. And again, if we wanted to, we could have just plugged all of those, the A and the B and the C, into this formula, and we would have ended up with exactly this thing right here. The point is not to plug things into a formula. It's to show, like, these are the steps you would take. You would factor something out, and you would divide by 2, then you'd square it, you'd do this, and you'd do that, and you'd end up with something like this. Now we're just going to check that this thing does indeed equal this thing. So I'm going to erase this stuff. You got all this stuff right here?
Yeah.
Okay, we're erasing this. So I'm going to check, is this thing equal to the thing that I got? Well, let's square that out. X minus 1 squared is x minus 1 times x minus 1. There's no other terms we need, so that's pretty easy. First, outer, inner, last. First gives me x squared. Outer gives me minus x. Inner gives me minus x. -1 times a -1 is a +1 for a total of x squared minus 2x plus 1, which is what we started off with. And so there we go. That if this were problem A, it looks a lot like problem A. If this were problem A, we would be done. With both problem 1, sorry, yes. If this were part A, we'd be done right now with both problem 1 and problem 2, because we did the problem 1 part to derive this. And then with problem 2, we took that and multiplied it out to check that, yes, that is the same exact thing as that. Okay, any questions?
No.
Okay, so this one is, I had to throw one in without an A term, or where the A term was 1. The other ones are going to look much more like this, and this is going to help us much more. So let's do one similar to problem B, and let's do 2x squared plus 4x. How about plus 3? Okay. Step 1, give yourself some room. So I'm going to rewrite this like this. Okay. Now, factor out the A term, right? That's what this says right here. So I'm going to just make this look like this. I'm going to give myself some parentheses and put my plus 3. What's the A term that gets factored out here?
2.
2, leaving me what inside?
2x squared. No, x squared.
X squared
Plus 2x.
plus 2x. And notice I'm not writing it like this. This says to take whatever B is and divide it by A. Well, that's what I did. Now let's check. Let's make sure that this works. If I distribute the 2 back into the parentheses, I get 2x squared. Good. Distribute the 2 back into the parentheses, I get 4x. Good. The 3's on the outside, stays as 3. Hey, this is exactly the same thing as this. It's just written a little bit differently. Okay, cool. The next step says to take half of that term right there, right? right? B over A, you throw a 2 in the denominator. The B happened to be a 4. The A happened to be 2, right? This is my B over A like that. We're taking half of that, or in other words, adding a 2 into the, multiplying the denominator by 2, not adding. I said adding in a 2. Introducing a 2 into the denominator will give you that right there. If we were just plugging things in, that's what we'd have, but we don't have to think about it that way. When I see this, I think, oh, that's half of whatever that number is. That number's 2. What's half of 2?
1.
1. So again, now we have a plus 1 squared. That's what's going to complete my square, but I can't just add in a number without changing it. So I'm going to subtract off the same number so that this is exactly equal to that. And let's just check it. Let's make sure 1 squared is 1 minus 1 squared is 1. So 1 minus 1 is gone. Okay. Then I would have the 2 times x squared plus 2x all here in parentheses. Okay. Then I multiply my 2 through and I get 2x squared. Yep. The 2 comes in. 4x. Yep. I haven't changed anything. This is exactly the same thing as that. So we're good. But now, the whole reason I did that, I could have added in any number in the world, but I chose to add that one because it makes this a perfect square. What perfect square does it make it?
X plus 1.
X plus 1. The way I knew that is because the way we set it up, it's always just x, so x is just by itself. That sign is a positive, so that sign's got to be a positive. And then whatever number is inside that parentheses, happens to be 1 in this case, shows up right there. And then if I don't believe it, I can check it. And that's what we should be doing at this point in our lives. We should be going, wait a second, let's make sure that this is equal to that. If I squared that out, first, outer, inner, last, my first would give me x squared. Yep. Outer would be 1x, inner would be 1x for a total of 2 x's. Yep. 1 times 1 would give me a plus 1. Yep. Subtract off the 1 is still there. Yep. So this is exactly the same thing as this. And we've already checked that this is exactly the same thing as this and that. And so we're still good. We have not changed this number at all. Okay, so now we're at this point. What does my next step say to do? Well, it says to distribute this guy back in. That's what changes from there to there. We're taking the A and distributing it back into these two terms right here. So the A comes in, hits there, A comes in and hits there, and this is what it's going to look like. The 2 jumps over and gives me 2 times x plus 1 squared. The 2 jumps over and gives me minus 2 times 1 squared. Now I could drop parentheses. There's no reason to have these parentheses because I've multiplied this guy back in. The only thing left is that hanging 3. It's just hanging out there. Okay. I can make this a little bit easier. 1 squared is just 1. So this comes out to be that minus 2 times 1 is 2 plus 3. What's minus 2 plus 3?
Plus 1.
Minus 2 plus 3?
Plus 1.
Yes. I just couldn't hear you. I'm hearing Grover and Prairie Dawn and all of our friends from Sesame Street right now.
Okay.
So, okay. So there we go. Now that is in the form that we want. And again, right, I haven't written it like that. That's fancy. That's nice and fancy. That helps us get a general formula if we want, right? But that's not really what we're doing. Again, and here's another thing. If I wanted to just use this as a formula, let's see what I would have had. This says to take A, I guess A is 2, yep. Then it says take X plus B, which is 4, over 2A, so that's 2 times A is 2, okay, so A is 2 squared, plus 4 times A times C. 4A is 2. C is 3. Okay, there's that. And this is all over 4. A is 2. There's a B squared there. B is 4, so 4 squared right there. And hey, lo and behold, look at that. That reduces to that. I could have used this as a formula, but I think, oh, that should be a 1. 4 divided by 4 is 1. 4 times 2 is 8 times 3 is 24, I believe. Minus 4 squared is 16. 16, 17, 18, 19, 20. So that should be an 8 on the top. That comes out to 8 over 4 times 2 is 8. So 1. So all of that reduces down to 1. And yeah, we get the exact same thing by plugging it into a formula as we got by doing this. But as you could see, like, I don't know about you, that just seems really convoluted. And I'm never going to remember all of that right there. I'm certainly going to mix up a C and an A, and that's just not going to happen. It's not going to look good. But this right here is pretty simple, right? Factor that out and this and that. And then sometimes it works out really nicely where you don't end up with something that looks this ugly because it just simplified before you even got to it, really. Like in the case where it's 1 and you're dividing by, 1 and you have multiplying by 2, it looks nice and easy and so on and so forth. Okay, so there you go. We have done part 1 to turn it from something like this into something like this. Any questions about that going through?
No.
Okay. So let's check it. Let's see if that is indeed the same thing. So here's part 2. We're going to say, okay, is this thing equal to the thing that we got, which is 1 squared plus 1. All right. So I'm taking the number 2 and multiplying it by something squared out. So I'm going to use brackets to square that guy out like that. Don't have to use parentheses, but you definitely should use something because we don't want to forget that that 2 is multiplied by that entire thing. Great. Here we go. Okay, please, Kayla, first outer, inner, last that for me. What do we end up with here?
Brackets. Hold on. Okay, there we go. What did you do? Okay, yeah.
Okay.
X squared.
Yep.
Plus 2x plus 1.
Mm-hmm. Okay, good deal. Now let's multiply that 2 through. We get 2x squared. 2 times 2x is plus 4x. 2 times 1 is plus 1. I'm sorry, plus 2. 2 times 1 is 2, last time I checked. And then we have the plus 1 on the outside. Now that we've distributed that through, we don't need parentheses anymore. So I'm going to drop them and just write it like this. And finally, I could go, okay, there's 2x plus 4x, and 2 plus 1 is 3. And indeed, yes, that thing is just a fancy way of writing the original thing. They are exactly the same thing. Okay, looking good. Questions?
No.
No, okay.
Yeah,
So, okay, thus far, we've either had an A that was 1, in which case it made everything very easy, or we've had a B and an A that divide evenly, right? When we factored out the 2 from a 4, we ended up with a 2. In other words, 4 divided by 2, right? That's what we had here. 4 divided by 2 in this step turned out to be a nice whole number, and that was easy to deal with. And so we just plugged along. Let's see what happens when it's not a nice whole number. So let's say we have something like this. Again, 2x squared, and we're going to go minus, we'll do minus 3x. And Why not? We'll just do -2. Okay. Okay, what's my first step?
Factor out of 2.
Yeah, let's give ourselves some room first.
Oh, okay.
I told you you're gonna hate me. I said this, on Friday. You're gonna hate me for this step, and I hate myself for that step. But yeah, let's give ourselves a little bit of room. And yes, in practice, when you go to do this, you'll just write it. You'll go directly from there to writing it like this because, yeah. But I'm making a point here is like, you're gonna need room, right? You're gonna need room on your page to do this. Okay, so now what do?
Now we can factor out a 2.
Now we could factor that guy out. So I'm gonna write my parentheses first. That's how I like to do it. I can see about how big it needs to be. And I'm gonna go ahead and take care of that -2 on the outside so I don't forget about it. Now the action's starting. Factoring out a 2 brings a 2 out here and leaves me with what for this term?
-3 over 2x.
Yes. And at this point, remember what I was talking about faith and belief last time? Like, this step is, for me, it's kind of just on faith, right? It's like, well, this says that I could factor out an a by throwing it into the denominator. And so I'm just going to kind of do this step right here, just on faith. I'm going to take these symbols, and I see, oh, there's a b, that's my b, okay. And if I want to pull the a out, which I do, it says that I need to divide by a. Okay, well, let's do what we should be doing with every step. We took a new step, and let's make sure that if we went backwards, then we would end up with the same thing. I think it's pretty easy to see the 2 would come in. Yeah, good. And then when the 2 comes in and hits this guy, what happens?
You get a 3.
You get a 3, right? Because the 2 jumps over and you have -2 times 3 over 2. They cancel out, right? Just like if we were checking this guy, you'd say, well, the a comes in and, oh, it would kill the a, leaving you with just a b. And here I could see, yeah, the 2 comes in, kills the 2, and leaves me with just a 3. Oh, yeah, it's the same thing. Okay, cool. Now, we have to take half of that because we want a perfect square. And we know that when we square something, when we FOIL something out, the outer and the inner get added together. And if the outer and the inner are exactly the same thing, you're going to get 2 times as much. So this is already 2 times as much of whatever it is. So we need to take half of it. What is half of that number right there?
Hold on 1 second.
Okay.
Okay. Let's see. 3, 4 over 4.
3 over 4. And if I'm just going with this again, I could just take this on faith and go, well, this right here, because this is the step I'm on, I'm about to add this weird 0 into there. And this says that if I have a fraction, I just multiply that denominator by 2. My fraction here, b over a, happens to be 3 over 2. And so if I need to take half of it, this says I just throw a 2 into the denominator like that, right? The b over 2 times a. And I can look at this and say, oh, okay, well, I'm not going to write it like that. I'm going to write it as 3/4. And indeed, 3/4 is 1/2 of 3/2, right? And you can see that because, like, remember what this thing is going to do. When we do outer, inner, last, these 2 things are going to be added together. In other words, 3 plus 3, or 2 times 3 over 4. And what do you know? The 2 and the 4 cancel and you're left with 3/2. Yeah, that's the whole point. That's why we're taking half in the first place, in order to make this a perfect square. So we take half of that, which is 3/4, and we square it. Be a perfect square. But we can't change, that will change the overall number. So we have to minus off 3/4 squared as well. Now let's just visually inspect and make sure we've taken a new step. So let's make sure that when we go backwards, everything works. 3/4 squared minus 3/4 squared is 0. Good. And then, well, without those, this is exactly the same thing as that. And we've already checked that when you distribute the 2 back in, you get that. Okay, that looks good. The -2 is just coming along for the ride. So we have not changed this thing at all. This is exactly the same thing as this. We're good to go. Okay, the whole point of doing this, and in fact, the whole reason that I like to write it this way as something squared, you'll notice I didn't say, don't write this down. I didn't do this. I didn't say, well, I'm trying to complete a square. Half of that would be 3/4. But then if you squared that, that would be plus 9/16. So I'd have to minus 9/16. Like, yes, that's what that means. But I didn't write it like that, because if I did write it like that, then the next part where I factor that square out, it's going to be kind of hard to see. This is really easy to see. It's like, oh yeah, that right there, that is the number, right? That is going to show up right there. Because my next step is to turn this thing into a perfect square like that. And it just so happens to be that, yeah, when you square this out, you get what, when you go first, outer, inner, last, the last thing that you have is the b/2a that gets squared right there. Well, that's the thing that gets squared. So that's the thing that's going to go in there. That's what kind of, it's one of the nice things about doing it this way. It takes a lot of the guesswork out of it. I could just say, well, this right there is a perfect square. That's why I did what I did. I know it has to be 1x. I know it has to be a minus right there. And then whatever the thing is that's getting squared is the thing that shows up there. So it's 3/4. And then I take it and square that guy. And indeed, right, that matches with this step right there. That looks exactly the same. We've just picked up a 3/4 squared -2. And there we are. We are in this step. We have now completed this step. Now I'm just going to check, because we've taken a new step. So let's check it. First, outer, inner, last, this guy. First will give me an x squared. Yes. My last will give me a positive 3/4 squared. Yep, that's what that would give me. My outer and my inner would be a minus 3/4 x minus another 3/4 x for a total of minus 3/2 x. Yep, that's what that is. Good to go. We have that. Who comes along for the ride. But then in this step, he would kill that guy, and we would be back to here, which we've already checked. Works for this and this. And so we could conclude that if you just went and multiplied this out and did a bunch of stuff, you would end up exactly where you started, right there. So it's equal to the same thing. The next step is what? So what happens from, I'm trying to look at here. What happens from here to here? What do we do?
I just realized I'm muted. I was
Oh,
too. I
just assumed you were swearing at me under your breath.
I was saying it over and over, like, distribute the 2, distribute it. Hello.
And I'm like,
I'm telling you.
Okay, yes, we distribute the 2, right? And here, just looking at the roadmap tells me, take whatever you took out in the beginning, throw them back in, and then drop your parentheses. Okay, so we distribute our 2. That gives me a 2x minus 3/4 quantity squared minus 2 times 3/4 squared. Finally, minus 2. Now here's where, and this is kind of where this is paying off, because I could see this And I could go, well, yeah, if you really wanted to, you could take each one of these steps. But I have a feeling it'll be easier to just calculate what this is. And maybe something will reduce and it'll be nice and easy. We'll see. So I'm just going to do this, copy this down exactly. I'm going to go -2 times 3/4 squared is 9/16. So that's 9/16. But the 2 in the numerator and the 16 in the denominator cancel out. And so I get a 2 here, and 8 is left over, excuse me, in the denominator. And so I have 2x minus 3/4 quantity squared minus 9/8 minus 2. Technically, we're done. I mean, but let's rewrite 2 as something 8s. 2 is equal to how many 8s?
Wow, hold on. 16.
Yeah, because 2 times 8/8 is 16/8. And so, yeah, there we go. So I'm gonna, just to save myself room, I'm gonna rewrite it just in place right here. And instead of writing -2, I'm gonna write -16/8. -9 minus 16 is what?
-25.
I think so. -25. There we go. That's our answer. Again, if we could memorize this, we could have taken each one of these numbers, 2, -3, and -2, plugged it into this formula, and after some cancellation, it would look exactly like this. I don't like that. That's not the point of what we're doing, because it's like, where did this formula come from? It's magic. Well, no, it's not like a magic formula. It's what you do. It came from what we just did, these steps, right? So I'll stop with that. I won't go into that anymore. I'm sorry, I just started erasing this. Can I erase this so we could go to check it?
Yeah.
Okay, cool. So now here's the big question. So that was problem 1 done, right? To find this form. Now problem 2, we are going to check it. Is this thing, the given thing, equal to 2x minus 3/4 quantity squared minus 25 eighths? Well, we just saw that it was exactly the same. Let's make sure. So in other words, we're going to go kind of backwards here and say, okay, 2 times something that I'm about to square out. So I need parentheses, minus 25 eighths. The thing I'm squaring out is x minus 3/4 times x minus 3/4. First, outer, inner, last gives me minus 25 eighths. Well, first gives me x squared. Outer, inner give me minus 3/4 x minus 3/4 x. We've already done this, but I'm just going to really drive the point home. That is the same as -3 minus 3/4, or -6/4, which, what do you know, is -3/2. So yes, or another way I could have done that is said, oh, you're squaring out a binomial. So it's that squared. The sign stays the same. Multiply the middle thing, or multiply the second thing by 2. And yes, 3/4 times 2 is 3/2. So 3/2 x. A negative and a negative is a positive. So it's going to be positive. And in this case, it'll probably be easier to go ahead and just square that guy out. I'm going to say 3 times 3 is 9. 4 times 4 is 16. So there we go. Okay. Now what do we do?
Distribute back in the 2.
And so we get 2x squared. Then what?
Then Minus 3x.
minus 3x plus
9/8.
there we go, 9/8. And now we could drop the parentheses. So minus 25/8. 9/8 minus 25/8 is how many eighths? How many?
Hello?
Hello? I want to know how many eighths.
Hello?
Hello? Can you hear me? I can hear you. I
Can
can
you hear
hear
me?
you. I hear you. Can you hear me? Yep, you're frozen. You can hear me. That's a
Am I
thumbs
still
up.
frozen? Am I still frozen?
No, I can. You're not frozen. You're now moving, and I saw your thumbs up. Can you hear me?
All right, we're good now. Yes.
Okay, cool. Okay.
Sorry.
No problem. No problem.
Uh,
So 9/8 minus 25/8 gives me how many eighths?
2 minus, well, I guess 16.
Minus 16/8. I just want to be extra careful about this. So I'm taking it step by step. Then 16/8 is the same thing as 2. So 3x minus 2. Lo and behold, this thing is exactly the same thing as that. It's just written in a way that helps us out. So, okay. So that's what those are like. We have one that's gonna get uglier. Let's see, how are we doing on time? Okay, so let's do a couple really ugly ones. So, okay. Yeah, buddy. So let's do 1/3 x squared minus x plus 1. Okay. First step is give yourself some room. So I'm going to give myself some room. Yeah. Okay, now we got to factor out that third. And how do we factor out a third? What does that end up doing? Well, there's a couple ways we could look at this. If we're just blindly following along with our roadmap, we could say, well, that's the A right there. That's the B. The B happens to be 1. And so this says you take whatever B is and divide it by A. Well, the B is a 1, and the A happens to be 1/3. So dividing by a fraction is the same thing as multiplying by the reciprocal. And so in this case, it just comes out to 3. So here's my step on faith, right? I'm just going to say, well, I could get from here to here by just dividing without using my brain. So, and it tells me that B over A is equal to 3. So let's just see what happens. Oh, another thing to notice is that's a minus sign. So we're going to have to preserve that minus sign and go 3x like that. So there's the step on faith, but let's just check and see if everything's still the same, right? That's what we should be doing every step along the way. We've just taken a step. Now let's make sure that we haven't actually changed anything. The 1/3 comes back in and hits the x squared to give me 1/3 x squared. So that looks good. What about this? Well, the 1/3 comes in and hits the 3x. And oh yeah, that's actually easy to see that the 3's are going to cancel and I'll be left with just a minus x. And so when he comes back in, I just get a minus x. Yep, and that's what I want. So good, actually, I have not changed anything. Okay, good to go. Now, did that make sense? Do you believe this?
yes.
Yeah, and so again, if it's like, and especially when they're fractions and when one's a fraction and the other one's a fraction, it can be real hard to think about. But what I kind of do is I don't do so much the 1 divided by 1/3. I just think, well, I'm factoring out, this means I'm dividing by a fraction. Factoring means dividing by, right? I'm dividing out. Divide by a fraction means multiply by the reciprocal. So whatever that is, if it were 1/3 and I'm pulling it out, well, then I would need a 3/1 over here to undo that, right? So let's just real quick, let's say it was even uglier. Let's say it was 2/3 x squared plus, let's go 7/5 x. You could say, well, factoring something out means dividing by. Dividing by a fraction means multiplying by its reciprocal. So let's just multiply this thing by its reciprocal. And we'd have this right here. And it would be really ugly. But we'd say, well, but the checking part is really easy, actually, because I can see, yeah, the 2/3 comes back in and hits the x squared. Yep, gives me that. 2/3 comes in, cancels the 3/2, because we have a 2/3 times 3/2. And what do you know? The 3's and the 2's are going to cancel when those guys get back together. So there you go. Similarly, that is exactly that step. We have b over a. B is this. Over a is this. 2/3. You have 7/5 multiplied by the reciprocal of 3/2. Oh yeah, that's what you have right there. And yes, it's going to look really ugly when you actually multiply it together. It'll be what, 21/10 or whatever. And so finally we would have 2/3 x squared plus 21/10 x. Just to kind of finish this up, we take half of that. How do we take half of that? Well, multiply the bottom by 2. Half of that would be 21/20, I guess. Yep, that's half of that. And then we take it and square it, minus it off. But that's not what we're doing right now. But this is just, if it were even more complicated than the ones I gave you, the principle is still the same. When you factor out a fraction, you're just multiplying by the reciprocal. It means the same thing. And so we kind of have that as a rule of thumb. But I'm going to check it every time I go and just make sure, like, yes, when the 3 comes back in, it kills the 3. And that's so, yes, this is exactly the same as that thing. Okay, so I'm going to copy this down. Minus 3x. Give myself some room. Plus 1. Now, I'm going to add what squared?
Well, 1/1/3 times 2, right?
1 oh, well, yeah. So yes, 1/1/3 times 2, yes. But we just found that 1/1/3 is actually equal to 3. Now remember, like, and this is what I kind of mean by getting lost in the weeds. Like, to go from here to here, you're kind of thinking like, well, we need b divided by 2a. But remember what that is. That is half of whatever this number is. What's half of 3?
3/2.
Yeah, exactly. Yeah, that's where it's tricky. 3/2. And so again, we don't want to get caught up in, okay, I'm going from this step to this step, so this needs to exactly match this. It's like, well, yeah, but that b over a, remember in our first case, our b over a was a 2, right? It turned out that b was 4 and a was 2. And so we didn't write it as 4/2. And then when we asked, well, what's half of that number? We didn't go, well, hold up, it's 4/2 times 2 in order to make this fit into there. This is just a longhand way of saying, hey, take half of whatever this number is. B over a, in our case, happened to be a whole number. So we don't need to think about it as a fraction. We could, well, we will, but it's just some number. Half of it is whatever that number is divided by 2. And so, and this is part of what's so difficult about this, because I'm telling you, use a roadmap. And then I'm like, but don't use it too closely, right? Like you kind of use it here and there. But that's the idea, right? Is like from here to here, I'm thinking, well, what is this? Well, it's half of whatever that number was. And yes, we could have written it as 1/2 times 1/3. In which case we would have 1/2 times 3/1, because divide by a fraction is multiplied by a reciprocal. And so we would end up with there. In this case, it's easier to just say, wait a second, this is just telling me to take half of that number. And so in this case, I'm going to say, well, half of this is just that. And so that's what we're doing. So we're taking half of whatever the middle thing is. It looks complicated because it's in this general form for any numbers A, B, and C. But if we remember what that means, it simply says take half of that. So we took half of that. And now that we've taken half of that, that part reduces. So I'm going to go ahead and fill in all the stuff that's not moving this time. This thing is changing. And what does that work out to be? It is a perfect square.
X minus 3/2.
Mm-hmm. Okay. Oh, we didn't check our last step, but we checked the one before it. We know that when we throw that 3 back in, it goes back to what it originally was. This, pretty easy to see, that 3/2 squared minus 3/2 squared is 0. So that guy comes out to 0. And what do you know? That's exactly the same thing as this, which is the same thing as this. Okay, so we're still good. This now, we've changed from this to this. And I could see, yeah, first, outer, inner, last. If I squared that out, we would have x squared. Yeah. Minus 3/2 minus 3/2 minus 3/2 minus 3/2 is the same thing as minus 3, or minus 6/2, which is minus 3. Okay, so that works. Finally, we would have that times itself is going to be a positive 3/2 squared. Yep, that's what that would be. And so, okay, we look good. Next step, we're going to distribute that, whatever that number is, back into this thing. And so we have 1/3 x minus 3/2 quantity squared minus 1/3 times, oh boy, how do we want to do this? I guess I'm going to write it like this. I'm going to go ahead and square it out just to save ourselves a little bit of time here. The 3/2 times 3/2 is the same thing as 3 times 3/4, or 9/4, but I wrote it like that so that we could see, oh yeah, when that 3 comes back in, this guy cancels one of those guys. And I'm left with minus 3/2 squared minus 3's are gone, and we're just left with 3/4 plus 1. But 1 is 4/4, so I'm just going to go ahead and write it that way. Plus 4/4 minus 3/4 gives me a total of what?
I'm still writing.
Okay, yep, take your time.
One quarter.
I believe so. 1 positive 1/4. So yes, 1/4. All right. That's that guy. Now, we have taken painstaking measures to make sure that every one of these steps, we didn't actually change the number. It looks different, but it's written, but it should be exactly the same. So let's verify that. So we are going to check that this thing is still equal to the thing about 1/3 x minus 3/2 squared plus 1/4. That is equal to 1/3 times something times itself, which is that x minus halves times x minus 3/2. So would you FOIL that out for me, please?
Okay, so x squared
Yep.
minus 3x.
Yep, I'm just gonna double check you right there that, yep, we had the outer inner was a minus 3/2 and a minus 3/2. So a minus 3/2 minus 3/2. It's the same thing as minus 3/2 plus 3/2, which is minus 6/2, which is minus 3. Oh yeah, it's twice as much as that thing. 2 times 3/2 is 3. So minus 3x. Okay, finally, what do we get from our last multiplication?
9/4.
Plus or minus?
Plus.
Plus. There we go. Okay. So again, haven't changed anything. It looks different. Just multiplied it out. Still the same thing as what we started with. Okay. Now let's multiply that 1/3 back in and see what we get. 1/3 x squared. Then what?
Minus x, I think.
Minus x, yep, because the 3 times the 1/3, the 3's cancel. You're just left with the 1 on top. And so since it was minus, it stays minus. Okay. Now what happens with that 9/4?
You get a 3/4.
There we go, because 9/4 like that. 3 on top, so that should be a plus 3/4. Yep. We're done with parentheses. Done with parentheses, and so plus 1/4. Can we simplify that at all?
Yeah. And you get a +1.
You get a +1 because that's 4/4, which is just +1. That is exactly what we started with. Therefore, that is exactly equal to that. It's just written in a way that helps us out. Okay, all right. Okay, so that is one with fractions and stuff. Let's do that. One was really ugly, so let's do that. So, and let's do 3 and yeah. Okay, we're gonna do it like this. All right. Starting to get into the flow of these things. Are you starting to see how this kind of works? See, and that's, when you see it like this, it's like you could really get hung up on, well, wait a second, I should write this as this over 2 times this. And it's like, not really. This is just to help you to remember, wait, what was the next step? Oh yeah, you took half of something. And that's why it looks like this, because we're trying to do this in general for any 3 numbers, A, B, and C. And so, yeah, it would look like this, but all this is saying to do is take half of the middle thing, take half of that, and it would look like this, yes. But if your B over A happens to be 6, then half of that would be 3. And so you don't need to write it as a fraction, but so that's the idea behind this. So let's do, oh, I knew what I wanted and then I forgot. So how about, we'll do 3 and 5, minus 3x squared. So that's a minus 3x squared plus 5x plus 4. Have you noticed yet that this number really doesn't matter, right? And like it just, the last number, in this case, +1, doesn't come in until like the very end. And you're like, oh yeah, it's really like an afterthought, you know? And that's just something to notice, like, could have been anything. And at the end, you're just going to say, well, whatever fraction I end up with out here, I'll just turn that into the same kind of fraction and just put them together. And that's really all that step is. But at any rate, okay. So first step, giving myself some room. So we have a minus 3x squared plus 5x, big space, plus 1. Now, what am I factoring out?
A -3.
A -3. And that's the tricky part about this, is that there's a -3. So yes, we're pulling out a -3, leaving me what inside the parentheses?
Yikes. Okay, x squared. Plus 5. No, minus 5/3.
Yes. The way that what went through my head was this. I'm factoring out a negative number. So that means it's going to change whatever sign that is. If that sign's positive, it's going to become negative. If it's negative, it's going to become positive. And at this point, I'm really just doing this on faith, is that, well, whatever I factored out has to go in the denominator. And so this point right there, it's just faith. But now here comes where I'm going to start to believe it. Is I'm going to check this step that I just did. And I'm going to be explicit here. I'm going to actually write all of this out. We have our -3, which comes in and hits the x squared. This is a minus, and so the -3 comes in like this, 5/3. I see it jumping in on the left-hand side right there. That's just what I imagine, is that -3 jumps in like that. And it looks like that when it does. And then I see, aha, a minus is a positive. And so this minus is going to become positive. The 3 and the 3 are going to cancel, and I'll be left with 5x, which is exactly what that is, which is exactly what we started off with. And so I feel good about this. I feel like, yep, that really did work. I pulled out a -3, got that and that. If I brought the -3 back in, I would end up exactly where I started. So I'm feeling good. All right. Minus 5/3 x. Okay, I'm going to take half of something. What is half of that thing?
Five over 6.
Yes, 5/6. In other words, if you take a fraction and double the denominator, you have just halved the fraction, right? And just to be sure, like you have half. I know that half of a half is a quarter, but I'm going to say, well, what happens if I double that denominator? If I double the denominator, 2 times 2 would be 4. And I can see, yeah, that is half of that original fraction. And so half of a fraction, and I can look over at my roadmap, which says, throw a 2 into the denominator, multiply that denominator by 2, and say, oh yeah, that's what half of it is. And so it's going to be plus 1/2 of it squared minus 1/2 of it squared. Double check. This minus that is 0, goes away. So all we're left with was this line right there, which we've already checked. After multiplying that -3 back in, we end up with our original thing. So this is exactly the same as that. I haven't changed anything. Now, this says to utilize what you just added on to turn this bit right there into a perfect square. Okay, and so it should look like this. I'm writing in all the parts that haven't changed first. That's just how I like to do it. And what is this guy going to be?
X minus 5/6.
Yep. Should be. And I could double check first, outer, inner, last. If I went and multiplied this guy out, right? The minus this out here, this last bit is just going to come along for the ride. That's not changing. But if I multiplied this out, I would have first gives me x squared. Yep. Outer is minus 5/6. Inner is minus 5/6 for a total of minus 5/6 minus 5/6, which is a total of 2 times the original thing, 2 times negative 5/6, which is, what do you know, minus 5/3. That's how many x's I have. Yes. Okay, we're good there. The last would be 5/6 times itself, and it would be positive because a negative times a negative is a positive. Okay, yep, that works. 5/6 squared. That looks good. I think that this is exactly the same thing as this, which is exactly the same thing as this, which is the same as this, which is the same as this. All right, feeling good. Now what do we do?
Distribute the 3.
Distribute the what 3? What type of
negative
3?
3.
So that's, don't forget the flavor of the 3. It's a negative 3. And so we're throwing the negative 3 back in. That gives me a negative 3. X minus 5/6 squared minus a negative 3. We could have done this another way. I'm just going to write it like this. Just throw in the negative 3, and I could see that, yes, negative will make a positive. But we'll get there. 5/6 quantity squared. I could drop parentheses plus 1. Okay. A bunch of ways I could take care of this. I think the way I'm going to do it is like this. Minus 3x minus 5/6 squared. Minus minus is a positive. Plus 3 times 5/6 squared is 25 over 36. Plus 1, not forgetting about my plus 1. 36 is 3 times something.
12.
Is it? Yeah, that sounds right. So 3 times 12. Thank you. Thank you. So minus 3 x minus 5/6 squared plus, I'm just going to do it like this, 3 times 25 over 3 times 12, like that. 3's cancel. And so I have plus 25/12 plus 1. But 1 can be written in terms of 12ths. In fact, I'm going to rewrite 1 as, and I'm saving space here by erasing and rewriting, 12/12. So 25/12 plus 12/12 is how many 12ths?
37.
I think so. So we have minus 3 times x minus 5/6 squared plus 37/12. Now here's the thing. Here's an interesting thing that we haven't really talked about. You may, and I'm not sure if you're going to run into it in your homework or not. Sorry, I just erased that. But this is our final answer. Are we good with the final answer?
Yeah.
Okay, so that's what we got. One thing you'll notice, you might, and it depends if this is going to happen or not. It would depend on the problem. But you might get to a point here in your last one where maybe something cancels out of this. And you might say, like, if it were 36/12, well, yeah, I guess in that case, you would just rewrite that as 3. But if it, yeah, since that's nice and that'd be a nice whole number. But I don't know, if it were like 32/12 or something like that, and you might want to reduce it because, well, you can, and you'd have like 16/6 or whatever, and then I guess that would divide again. But the thing is, when you go to check it, it's going to be nicer to have it without being reduced than, because, well, if you remember what we just did, those numbers all came together in a certain way, and they're going to come together in that same way here in just a minute when we go to do it. So whether or not you choose to reduce it or not, once, for this, for your homework, once you have that final number right there, I don't care if it's reduced or not. Like this is perfectly good. This is fine. You don't need to reduce it. And if you choose to reduce it, it may or may not be harder to actually go and check it. So whatever. Now we're going to check. Is this thing equal to that thing? So here's the question. Is negative 3x minus 5/6 quantity squared plus 37/12. Is that equal? Well, let's see. Minus 3 times something I'm about to square out plus 37/12. The thing I want to square out is this. X minus 5/6 times x minus 5/6. So negative 3 is going to stay on the outside. Please FOIL this bad boy out for me. What do I get?
X squared minus 5 over 3x
Yep.
plus 25 over 36.
Okay. All right. Now, the 3 comes back in, giving me a negative 3x squared. And then what do we get?
Squared
Say again?
plus
I heard plus, and then you went out.
5x.
There you go. And I believe that, right? The 3 in the numerator cancels the 3 in the denominator, and negative make a positive. Only thing that's left is the numerator 5, and so 5x. Yep. Now what?
Minus over 12.
Minus what over 12?
No. Wait, sorry. Got ahead of myself.
Okay.
Wait, where are we?
So
5
25
minus 25 over 12.
minus 25 over 12. I believe you. I want to make sure we're multiplying by 3. Already taking care of the negative, so now we're just looking at the numbers. That's the same as 3 times 25 over 36 is 3 times 12. And oh, yeah. This looks very familiar. Minus 25/12. Now you see what I mean? Like, this was going to come out to give you that denominator. It always was going to give you that denominator because that's how we got it in the first place, right? Like, that's where it came from. And so if you went and changed this guy in that last step, this is what I was saying a minute ago. If you went and reduced that, well, now you'd have something with a different denominator. And it's like, well, I know what I'm about to do. This thing will end up with that denominator. So maybe I'll just keep it like this instead of reducing it or whatever. But at any rate, even if you do, it's fine because you'll end up doing this anyway. So plus 37/12. Okay, 37/12 minus 25/12 is how many 12ths?
Minus 25. Yeah, 12.
It's 12. Okay, so plus 12/12,
Which is just 1.
which is just 1, minus 3x squared plus 5x plus 1. Is that what we started off with? Yes, indeed. This thing written all crazy like that is exactly equal. There's no difference between that and the original thing that you started off with. So that's the idea with these. That's what you're doing. Is do you think that you're good to go for the homework?
I think so.
Cool.
I think I understand better now.
Yeah, and I know it's, and that's like I said, when you first see this, and maybe you do one example, it's like, okay, I think I get it. And it's so easy to get lost in the minutia and be like, oh, wait, shit,
Yeah.
something over 2 times something. What's that? And it's like, this is just, and like I've said, this is your roadmap, and it's just to remember which turns to take. And so when you go, wait a minute, what was the next thing? Oh, yeah, I factored something out. I know what that looks like. And if it factors evenly, great. We don't need to worry about fractions and stuff like that. And then you get lost and you go, wait a minute, what happens after the factoring out part? Oh, yeah, this doesn't mean that you take b divided by 2 times a. This means you just take half of whatever that number is. Okay, so if that number happened to be a 4, I would just take half of it. So it would be 2. And so, but again, this is like full generality right here with any 3 numbers. That's what your final bit would look like. And again, if I wanted to, I could have just plugged these numbers into this formula where the -3 is the A, where the +5 is the B, and then the +1 is the C. And you would end up with exactly this thing right here. But that's not going to help you. The whole point of this is to know how to turn this type of thing into this type of thing. It doesn't always look like that with those fractions and those numbers exactly. Sometimes it looks kind of, it's not too, this one was a pretty bad one, but some of the other ones we saw were pretty nice. It's like, oh yeah, you factor this out, take half of that, add it, subtract it, and you're done. So, okay. You good to go? So I want to, the homework is, I'm going to split this homework into 2 parts. Give me just a second. So I'm erasing all this stuff. Let's put the homework up. So let me look real quick. So this is homework 28, part 1. Will be letters A through let's see. Let's do A through E. A through E. And that is both problem 1 and 2, right? So that is, you're gonna go get it into the form ax minus h squared plus k. And then you're going to do part 2, which is you multiply this guy, that bad boy, back out to make sure it was your original thing. Exactly what we did today over and over again. That exact same thing. Part 2 is going to be E. What comes after E? F through, is it K? F through K. So this is 5 problems. This is 6 problems, I believe. And again, both of those are number 1 and number 2. Exactly what we did. We're changing it from the one form into the other and then going back and making sure that this does work back up to the original. And number 3. And remember, number 3, it's difficult because there's a lot of stuff, but it's nothing you couldn't have done like a month ago, where you're just taking stuff and plugging it in, right? It's, you're going to take a x squared plus bx plus c equals 0, and you're plugging in both. You're going to do these 2 different times in this case. Like earlier in the previous homework, I think I put in a plus minus and said we could do this at the same time for both of these. Can't do that over here. It's not going to work with this one. We're going to have to do the minus b plus b squared minus 4ac all over 2a minus b plus b squared minus 4ac all over 2a. And you just square this bad boy out, rearrange a bunch of stuff until you get this side to equal 0. Then you go back and do the same thing, but instead of a plus right there, there's going to be a minus right there. And it's not that bad. It's just a little tedious, especially since in this first case, in fact, I'm going to go ahead and write it out right here. What you're going to have to do is you're going to have a times that squared 2a. So that means a times, I'm going to do it like this thing times itself. And it looks like this, minus b plus square root b squared minus 4ac minus b plus b squared minus 4ac. Don't make the mistake of going, oh, you're squaring that up. So you do the plus and the minus. No, no. Like, you have to make sure you're squaring the same thing multiplied by itself. So there's the 2a and the 2a. And so this is going to come out to look like this. The denominators can all be multiplied by all together. So that would be a 2 times a 2 is a 4. And an a times an a is an a squared. And then in the top, and this is where I'm going to end for today, because you should know how to do this, you're going to have this type of thing, plus a square root, b plus a square root. And you are going to have to FOIL this bad boy out. First, outer, inner, last should give you a positive b squared. Outer, inner will give you minus 2b times that root. A plus and a plus will be whatever was in the root, which is b squared minus 4ac, but it's going to look like that right there. And so there you go. That's the idea. And that's going to get ugly and stuff like that. And well, it looks like we could cancel an a from the top and the bottom, but ultimately that thing is going to work out to look like this thing. And then you're going to need to break it apart and move things together. But I guarantee you that this, after you've broken stuff apart and rearranged stuff, this thing will equal 0. It's a little difficult, but you could do it. So let's see. I think that's it. Oh, to be clear, this is due Tuesday at 8.
Okay.
And this will be due, part 2 will be due Wednesday at 8.